So far we have learned how to plot two-dimensional graphs. In MATLAB, it is also possible to plot three-dimensional graphs. Let's see how do we plot a three-dimensional graph. So let's create a new script. Plot 3D, for example. So now say that we have a range of t from 0 with an increment of 0.1 until 6 times pi. So that is our range, and then we have our expression. X is equal to square root of t times sine of 2 times t. And also we have another expression y, that is, now this is going to be y is equal to square root of t times cos of 2 times t. And then we have the third expression, z, that is equal to 0.5 times t. So now we have a range of t, and then we have three mathematical equations or expressions. Now we want to plot all three, x, y, and z. So the command here is, if for two-dimensional plot we have a command plot, for three-dimensional plot the command is plot 3, and it is the same. We type in x, y, z, because we want to plot these three variables together. And then it comes the line specifier. We can specify the color to be red, for example, and then the property, let's say line width. We want to change the line width to 3, for example. So that's the property name, that is line width, and property value is 3. So we're gonna hit run, and that's our three-dimensional plot. So we have three axes here containing x, y, and z. That is corresponds to x, y, and z. So this is a three-dimensional plot. So we can also use include grid if we want. For example, grid on, and we can also include the x label. Let's say this is x, and we have the y label, that is equal to y, and then we have z label, this is equal to z. So when we hit run again, you're going to see that every axis has been labeled and we have a grid in the plot. So basically it is just the same command, but by changing the name of the command from plot for two-dimensional graph into plot 3 for three-dimensional graph. Now let's look at how do we plot mesh plot and also surface plot. So let's create a new script. Now to plot mesh plot, for example, we need a grid. So let's define two ranges. So we have x equals to -1 with an increment of 0.1 until 3. That is our first range. And then we have y that is equal to 1 with an increment of 0.1 until 4. So this is our range, x and y. So we have to create a mesh grid by typing x, y within a square bracket equal to mesh grid of x and y, which is our variable just now. Okay, so for example, if we hit run, we will see that we have this grids of coordinates that has been created. That is x, one is x, the other one is y. or we can maybe change this to 1 for us to see the grid more clearly. If I hit run, then you can see that here this is the grid for X and this is the grid for Y. So we have basically two matrix that has been created from this range by using the mesh grid command. So these are 4 by 5 matrix of X and also Y. Okay, now to create a mesh plot, now we need another matrix. Now say matrix Z is then equals to X multiply with Y. We need to use element by element operation to the power of 2 divided by X to the power of 2 plus Y to the power of 2. Okay, so this will be our third matrix. So when I hit run, I'm gonna remove this first. When I hit run, see that we have now three matrices. We have matrix X, matrix Y, and also matrix Z. From these three matrices, then only we can plot a mesh plot. So to plot a mesh plot, the command is just simply typing in mesh X, Y, Z. So when we hit run, then we see this is our mesh plot, and it is not so nice because we set the increment to be 1 because we want to see the matrix just now previously. So now we're going to change this to 0.1 again. Okay, now when we hit run, we'll see a very nice mesh plot that has been created from this command. And to create a surface plot, we simply change this command mesh to surf, and when we hit run, we got a same plot, but now it is in form of a surface instead of a mesh that we have just now. And again, we can also include label by typing the same command. X label is X, for example. Y label is Y, and also Z label is Z. So when we hit run, we're going to see that every axis X, Y, and Z has been labeled accordingly. So that is how we draw mesh and also surface plots in MATLAB. So from our surface plot just now, or mesh plot, we can change the color of the plot by typing in the color map command. So there are a few there are a few types of color maps that you can use. You can click on more help to see the list of color maps. Okay, these are the default color map is like this, and there are a few color maps that you can change to. For example, there is color map cool, the command. So when you hit run, you see the color has been changed. There is also color map flag. For example, if I hit run, then I got this color. Also, there is autumn. So I got this color map. Also color cube, for example, I got like this. And let's just go to the default one by typing in color map default. This is going to be the default one. Okay, that is how to change the color map. Now we can also change the view of how do we view this thing. this is the default view. The default view is view 3. The command is view. If you type in view 3, you hit run, it's going to be the view. This is the default view, which is 3-dimensional view, 3 for 3-dimensional, I believe. So now view, if you change view from 0, 90, you got a view from top. Now you see this is a view from top. So it is because the view command requires you to enter the azimuth and also elevation. So if you do help view, you'll see that here, that the view requires you to enter AZ and EL. AZ is the azimuth, EL is the elevation. So here's some example. You can see how to set the view. View 2 sets the default 2-dimensional view. This is 2-dimensional view from top. Azimuth is 0, elevation is 90, and so on. So if, let's say, we want to view from the front, let's go back to the default view. View 3 is the default one. Okay, now we want to observe from, let's say, from this side, from the x-axis, we want to look at from this side. So this is going to be view 0, 0, 0 azimuth, 0 elevation. So we're going to see from this side. Okay, now we go back to default. We can also look from this side. From this side, it is view 90, 0. So we're going to look from this side, we'll see something like this. Okay, that is how you change the view of your plot. Now we can also do animations with MATLAB. Let's say, for example, we have these two mathematical expressions here. So we have x is the range from -2 with an increment of pi until -2 pi with an increment of 1/100 until 2 pi, and we have y equals to sine x. So this should be the graph of this thing when we use the plot command. Let's say we use plot x, y. So we're gonna hit run, then this is the graph that we have. Now instead of typing plot, we want to see this as an animation. So the command that we use is comet. The first command that we can use for animation is comet. So when we hit run, we'll see that the graph is now plotted. The graph has been plotted with an animation of the curve that is going that is moving like a comet. That is why the command is comet. So it will end until when it hits the end of the range. So that is the 2-dimensional animation using comet. So if we have 3-dimensional, let's say we have this range of t from 0 until 0.1, 0 with an increment of 0.1 until 6 pi, and we have x square root of t times sine 2t, y is square root of t cos 2t, and z is 0.5t. This is what we have previously. So the command that we can use to create 3-dimensional comet plot is now comet 3 x, y, z. So when we hit run, we'll see that the graph is now plotted in an animation, as an animation. Okay. Now we can also create the same animation using animated line command. So first we need to define a variable h, for example, that is equal to the animated line. Then we define the axis range, and now we have our range of x. So x is now a linear space with the first element is 0 until 4 pi, and we want to have 1000 elements. So this is a linear space command just to create a range, and then we need a for loop for this animated line command. So we use for loop for k is equal to 1 until the length of x. So this should be around 1000 elements, so length of x. And then what we want to plot here is just simply sine of x. So we have here y equals to sine x of k, okay? And then we need to have this add points command, so that we will add from this from the iteration, we will calculate the sine of x for current k. For example, k equals to 1, so we calculate sine of x1, then we add the points to this animated line variable h. So at point h, x, k, y. And then we need another command, that is draw now, to draw. And then this will loop. So basically, this will draw point by point by point until we reach the end of the range of x, that is 1000, because our iteration here is from 1 until the length of x. So when we hit run, we will see the animation of the line that has been created. So during the animation, if let's say it takes too long, you can always press Ctrl C to terminate it, and then you will see the notification from MATLAB that operation terminated by user. And then why do we have to define the axis here? It is simply because if we do not define the axis, MATLAB will automatically create, generate the axis based on the current points. So since we have an iteration here, you will see what happens if I did not include the axis command here, the range of the axis. So it will be like this. You see that MATLAB plots the axis. MATLAB changes the axis every time the iteration is run. So we don't want that to happen. That is why we need to define the axis, the range of the axis earlier before we actually run the program. So we will uncomment this, and when we hit run again, you'll see that the axis is now fixed from 0 until 4 pi for the x, and from -1 until 1 for y-axis. And then this is our plot that has been drawn using the for loop. This is just an iteration, okay? By iterating what is the value of y, that is equal to sine of every value of x in this for loops. And then we add the point into the variable of animated line, and then we use draw now command to draw the point.